All right, the piecewise defined functions worksheet. Let's get going on the review parts. Rosalia invests $20,000 at 6% annual interest, compounded quarterly. Write an equation, predict the value of her investment after T years. Okay, well that's our starting amount times 1 plus the 6% compounded quarterly. And since it's compounded quarterly, we need to multiply this by 4 times for every year. So this should be the value of her investment after T years. We could, of course, simplify that into a 1.06 divided by 4. I'm doing this early in the morning. I might have been able to pull that off in my head. 0.015, so 1.5% every 3 months times T. So that looks like the equation we're looking for. And problem 1, how long will it take for that investment to double? So the question is, when will that $2,000 become $4,000? And our process along the way there, if we get rid of this 2,000 first, then we get 2 is equal to 1.015 to the 4t. We need to access that t that's up there, so we're going to take a logarithm on both sides. Move that over here where I have a little bit more space. It's going to be log 2 is equal to 4t times the log of 1.015, and then I will divide by 4 times the log of 1.015 on both sides to leave the t by itself, and our final answer will be, pull this in here, we're going to do the log of 2 divided by 4 times the log of 1.015. I got to put that in the denominator in parentheses, or it's only going to divide by one of them, and I do want it to divide by both of those things, and that gives me about 11.6 years. All right, let's see. For the next 2 problems, use this piecewise defined function. Okay, and to start with, evaluate each of the following: h of -5. So if this is h of x, then -5 fits in here. -5 is less than -3. It's not between -3 and 4, and it's not bigger than 4. So the -5 is going to go in there, and that's going to give me a -5 squared minus 3 times -5 plus 1. Looks like 25 plus 15 plus 1 is 41. H of 94. 94 is a number that's definitely bigger than 4. So I'm going to put the 94 only into this one. That's a log of 94 plus 6, which conveniently is a log of 100, which I know is equal to 2. Remember that that's log base 10, and we can write 100 as 10 squared, and the log is looking for the exponent, and that exponent is 2. Okay. And then finally here it says do 8 times h of 2 plus 4. Well, it's 2 that's going in the place of the x, and that is between -3 and 4. So this is going to be 8 times 2 to the 2 minus 4 power, and then we're going to add 4. 2 minus 4 is -2. 2 to the -2 is 1/4. So this is 8 times 1/4 plus 4, 8 times the fourth is 2, 2 plus 4 is 6 for that one. So 8 times h of 2 plus 4 is equal to 6. All right, what does this graph look like? Well, let's see. The changes are going to happen at -3 and a +4, so those are important points to look at here. -3 and a +4. And this transition, when I put a -3 in, it actually goes into this one. That's going to be a 9 plus another 9 is 18 plus 1 is 19. That is way off the charts on this one up here, so it's up beyond where I can see it. So on this graph, the way that it is scaled, I'm not going to be able to graph that part, but there's a parabola going on up there. I probably intended that to be a -1. That would change a couple of things here. Let's go ahead and make that change, and I'll make sure that that -3 is a +3 when you see it. So this would have been 25 here minus 15 is 10 plus 1 gives me an 11. Okay. So at -5, I'm still not quite seeing that on this graph, but with a -3, that'd be 9 minus 9 plus 1, -3 comma 1 is on this graph. If I looked at the -4 to just kind of get a shape of this, I know the -5, this would have been 6, this would have been 8, -5, 11 would have been up here somewhere. Okay. The -4 in there would have given me a 16 minus 12, which is 4 plus 1 is a 5, so -4 comma 5 would have been on this graph, and I can kind of see the parabola part of this over here. Okay. It's in a steep part. If I did a 2 to the, if I tried to put the -3 in here to see where this one was, that's 2 to the -7th. That's going to be very, very close to 0 down here. Even if I put a 0 in here, 2 to the 0 minus 4, let's go to some of the easy places. If I put a 4 in there, I get 2 to the 0, which is 1. So I know that this point is on the graph. Okay. And this is an exponential function, so but it stops right there. So this is going to be this part back here, very close to 0 with an open circle back there. And then log of x plus 6, well, we know at 4, log of 10 is 1, so that actually does pick up there. We know it's not going to get up to 2 until we're out to 96, so this is that logarithm function has already begun its major slowdown and is going off this direction. Okay. So that is going to look something like that. Okay. And each little piece, there's a domain and a rule for that domain, so everything less than -3 looks like this parabola. Everything between -3 and 4 looks like this exponential function, and everything bigger than 4 looks like this logarithmic function. All right, the cost for Jaron to 3D print and assemble a fidget block is $3, but with his current equipment, he can only produce 20 in 1 week. If he spent $400 on a new printer, he could increase his output to $45 a week and reduce his per block cost to $2.80. So complete the table below for the total cost of producing fidget blocks for this week, making sure to account for the possible purchase of a new printer. Okay, so what that basically tells us is up to the 20 here, he does not have to buy a new printer. It costs him $3 to print and assemble one, so this would be $30 for him to print and assemble 10 of them. 3 times 15 is $45 to print and assemble 15 of them. And he can get up to 20 of them, so this would be $60 for him to print and assemble there. But his total cost now, if he wants to make 25, he's got to drop $400 on a new printer. Okay, so there is here a $400 additional cost, but then his per block cost is now $2.80, so I'll do the 280 times 25 plus the 400. 280 times 25 plus 400. That's going to be 2.8 times 25. I thought that was a crazy big number. Times 25 plus the $400 for the new printer. This is now going to cost him $470 if he wants to do that. Okay. If he's going to produce 30, that's 5 more at the 280, or so the 400 plus 2.8 times 30 is $484. Times the 35, it looks like every 5 is another $14, so $498. And what did I say, another $14 onto that is going to be $512 to get 40 of those. Okay. Now, certainly after his initial expense, if he goes on weeks after that, then the weeks after that won't incur that additional $400, and things will be better off there, but he is going to have to work off that $400 purchase. So, write a piecewise defined function for this situation. The total cost based on the number of blocks, so let's do the cost based on the number of blocks in. We kind of have two situations here. We have when the n is less than or equal to 20, we were able to figure out the cost by just doing 3 times n. But when we wanted to figure out the cost for the n more than 20, we had to do 400 plus 2.8 times n. Kind of the way that I did the calculations, let me know exactly what that equation was going to look like. Okay. So finally, Jaden can sell a fidget block for $10, write a piecewise defined function for his profit, the revenue minus the cost for this week. Okay. So his profit based on the number of blocks that he makes and sells. In the first one, again, if he makes and sells less than 20, the 3n is going to be what it's costing, but 10n is going to be how much money he makes. So 10n minus 3n looks like 7n. So his profit will be 7 times the number of blocks that he makes. And his profit just for this week with the initial investment, or any week that he decides that he's going to buy that extra printer for more than $20, is going to be, we're going to have the 10n again for what he sells it for, minus the cost, which was 400 plus 2.8n. Simplifying that, we got a 200, or a 10n minus 2.8n minus 400, looks like a 7.2n minus 400. Okay. I don't know if it's possible. We could look, it could increase it to up to 45, but even the 7.2 times 45 is only going to be $324. So if he maximizes that in that first week, he's still going to lose $76 at the best case. That is it for the piecewise defined function worksheet.